Hello viewers. So in this video we are going to see multiplication of two matrices and various important aspects related to it. So let us get started. So first of all, multiplication of two matrices. So let's say you have a matrix A and matrix B. So let's say you have matrix A whose order is n by n, and let's say we have a matrix B whose order is p by q. So the product of these two matrices, matrix A into matrix B. So A into B is defined only when the number of columns of first matrix that is n should be equal to number of rows of second matrix, that is P. Right? So A is also called prefactor. A is called prefactor and B is called postfactor. So the condition for two matrices to be multiplied is the number of columns in prefactor should be equal to number of rows in postfactor. Number of columns in prefactor, that is the matrix which comes first. Number of columns in prefactor should be equal to number of rows in postfactor. Only then the product AB is defined. So that is n should be equal to P. Okay. So n should be equal to P. And now what is going to be the result of this product? The result of this product is going to be another matrix, call it as C. So the matrix C is, the order of matrix C is going to be m by q, that is number of rows in prefactor and number of columns in postfactor, that is C. C is of the order m by q. So this is how the matrix multiplication works. So product of two matrices is defined only when the number of columns in the first matrix is equal to number of rows in the second matrix. The resultant matrix which we are going to get is of the order number of rows in the first matrix by number of columns in the second matrix. So for example, let us take an example. Let's say A is 3 by 2 matrix. So here A has 3 rows and 2 columns, and let's say B is 2 by 2 matrix. So now you see we can actually multiply A with B because number of columns in A is equal to number of rows in B. So let us consider an example. Let's say A is 3 rows, 1, 2, 0, 1, 4, minus 1. For example, A is this and B is, so this is 3 by 2 matrix, 3 rows and 2 columns, and B is 2 by 2 matrix. Let us say 1, minus 1, 2, 3, for example. Okay. So this is 2 by 2 matrix. So now you see the resultant matrix, the product. So we usually denote product with AB, with the symbol AB, or we can use symbol C as well. Okay. So product AB is going to be of the order 3 by 2. Because number of rows in the prefactor by number of columns in the postfactor, that is 3 by 2. So the matrix AB is going to be 3 by 2. That means 3 rows and 2 columns. 3 rows and 2 columns. So now how do we exactly multiply? So 3 by 2, there are 3 rows and 2 columns. So that means there are going to be 6 elements over here. So this element is first row, first column. So listen to me, first row, first column. That means you take first row in the prefactor and multiply with the elements of first column, right? So corresponding elements. So 1 goes with 1, 2 goes with 2. So 1 into 1 plus 2 into 2. So first row into first column. So 1 into 2, 1, 2, 1, 2. So 1 into 1 plus 2 into 2. That is going to be 5. 1 plus 4. 1 square plus 2 square, 5. Next, what is the position of this element? First row, second column. Right? This position is first row, second column. So you take first row and you take second column here. So 1 into minus 1, 2 into 3. So minus 1 plus 6. That is again going to be 5. Right? So first row, second column. Next, similarly, what is the position of this second row first column? So you take second row in the pre-factor and first column in the post-factor. Second row first column, that is 0 into 1 plus 1 into 2. So 0 into 1 plus 1 into 2, that is 0 plus 2. 2. Next, what about this second row second column, that is 0 into 1 minus 1 and 3. 0 1 and minus 1 3. So 0 into minus 1, 1 into 3, that is going to be 3. Right? 0 plus 3. Next, third row first column. Right? So this is third row first column, third row second column. So third row first column, 4 into 1 minus 1 into 2. 4 minus 2, that is going to be 2. Then 4 into minus 1 minus 1 into 3. Minus 4 plus minus 3, that is going to be minus 7. So this is going to be the result of product of these two matrices. So that's the reason for this is we require a condition, right? The number of columns in pre-factor should be equal to number of rows in post-factor. The reason for this is because see, each row will have two elements and here each column will have two elements. So these corresponding elements should be multiplied. So for that to happen, how many ever columns are there here? That many rows should be here, right? So here 1 and 2 columns are there, that many rows should be there so that we have exactly the corresponding elements. So the number of columns in the first matrix should be equal to number of rows in second matrix. So the number of columns in first matrix should be equal to the number of rows in second matrix. So that is the reason that these two should be equal, right? And after that, the resultant matrix is going to be 3 by 2. So this is how the matrix multiplication is defined. Now, let us take one more example. Let us take, for example, let us take 2 by 3 matrix. So 2 rows and 3 columns. 1, 2, 3, 0, 1, minus 4. So this is 3 by 2 matrix, 3 rows or 2 by 3 matrix, 2 rows and 3 columns. We have 2 rows, first row, second row and 3 columns, 2 by 3 matrix, 2 by 3 into. And let us take 3 by 2 matrix. So 1, minus 1, 0, 1, 2, 3 for example. So this is 3 by 2 matrix. Now you see. So now, can we multiply these two? Yes, because you see the number of columns in first pre-factor is equal to number of rows in post-factor. So we can multiply them. And the resultant matrix is going to be of the order 2 by 2. Right? So number of rows in pre-factor and the number of columns in post-factor, that is 2 by 2. 2 by 2. So now you see. So now this is first row, first column. First row, first column. You see there are 4 positions over here. First row, first column, first row, second column, second row, first column, second row, second column. So first row, first column, first row, first column. You see, so 1 into 1 plus 2 into 0 plus 3 into 2. That is going to be 7. So this element is going to be 7. First row, first column. So this element is going to be 7. Next. So what is this position? First row, second column. So first row into second column. Second column is this. So that is 1 into minus 1, minus 1, minus 1 plus 2. 2 into 1, 2, plus 3 into 3, 9. So minus 1 plus 2 plus 9. That is going to be 10. 10. Next, what about the position of this second row, first column? So second row, first column. So 0 into 1, 0, 1 into 0, 0, minus 4 into 2, minus 8. Minus 8. Then second row, second column. That is 0 into minus 1, 0, 1 into 1, 1, minus 4 into 3, minus 12. 1 minus 12, that is going to be minus 11. So this is the result of these two, product of these two matrices, right? So let's say this is 2 by 3 matrix and this is 3 by 2 matrix. And the resultant is going to be 2 by 2 matrix. So next is the various possible scenarios. In general, matrix multiplication is not commutative. That means the product of matrices depends on the order. So A into B is not equals to B into A in general. But there are some special cases where A into B is equals to B into A. So we'll come to that later. So first of all, suppose let's say A is consider a situation where A is 3 by 2 matrix and B is 2 by 3 matrix or 2 by 2 matrix. So the first scenario which we have, first example which we have taken, that is this one, 3 by 2 and 2 by 2. So now you see here AB is defined. Matrix AB is going to be of the order 3 by 2. 3 by 2, right? But here BA is not even defined, right? So matrix BA is not defined because we cannot multiply B and A, taking B as the pre-factor and A as post-factor, because the reason is, so here you see if you want to do B into A, B is 2 by 2 matrix, A is 3 by 2 matrix. So the number of columns in pre-factor and the number of rows in post-factor, they are not equal, right? So here B into A will not be defined, right? When you are trying to multiply rows by columns, so here each row will have only 2 elements, right? So each row will have only 2 elements. In matrix B, each row will have only 2 elements, whereas in matrix A, each column will have 3 elements, right? So here we cannot have corresponding elements and then we cannot multiply. So this is scenario 1. And scenario 2 is, let's say A is 3 by 2 matrix and B is 2 by 3 matrix. So now AB and BA both will be defined. See here AB is going to be 3 by 3 matrix and BA is going to be 2 by 2 matrix. BA is going to be 2 by 2 matrix because AB is going to be 3 by 3, whereas BA is B is 2 by 3 and A is 3 by 2. So BA is going to be 2 by 2 matrix. So here in this situation both are defined. AB is defined, BA is defined, but their orders are different. So they cannot be equal, right? So they cannot be equal. So two matrices are equal only when their orders are equal and also the corresponding elements are equal. Here the order itself is different. So AB is 3 by 3 matrix and BA is 2 by 2 matrix. So they cannot be equal. And coming to the third situation, suppose their orders can be same, but their product can be different. For example, let's say A is 2 by 2 matrix, B is 2 by 2 matrix. So whereas, okay, here you see AB is going to be a 2 by 2 matrix, BA is going to be a 2 by 2 matrix, but their corresponding elements. So here the order is also matching. AB is defined, BA is defined, their orders are same, but the corresponding elements are not equal. So let us take an example for this. One example is, so one example is this. So now consider A is this 1, 2, 3, 4 and B is minus 1, 0, 1, 1. If you see this is AB. So this matrix is AB. AB matrix is 1, 2, 1, 4. Right? If you multiply rows by columns, you will get 1, 2, 1, 4. And if you see this is B and this is A. If you change the order, so in both cases we are going to get 2 by 2 matrix. Right? Here 2 by 2 matrix, here also 2 by 2 matrix. But you see the corresponding elements are not equal. Right? Here 1, here minus 1, 2, minus 2. In place of 1 we have 4, in place of 4 we have 6. So their corresponding elements are not equal. So although they both are defined and both their orders are same, they are not equal. So that's why I said in general AB is not equals to BA. In general AB is not equals to BA. But there are some situations where AB will be equals to BA. In that case we say A and B commute with each other. So we'll be talking more about it in the coming videos. Right? So that's it for now. See you.